Hello everyone, welcome to this video. In this video, we'll be solving this question which states that if H is given to be a set which consists of all the matrices taken from this group, which is a general linear group having matrices of order 2 cross 2 and whose entries has been taken from the set of real numbers, right? Such that we have a condition on this matrix A such that the determinant of this matrix A should be an integer power of n. So it could be written like this, where this n is what? It is an integer. It is an integer, right? So now we for this H, for this subset H of GL2 comma R, we have to show that this is a subgroup of GL2 comma R. Correct? So to prove that H is a subgroup of GL2 comma R, we have to show that first of all identity is present within it. Second of all, by any one step or two step subgroup test, this forms H forms a subgroup. Correct? So we need to prove it by the subgroup test in order to prove that it is a subgroup. So moving on to our first condition here for the identity part, you know what is identity present in this GL2 comma R? It is the identity matrix of order 2 cross 2, correct, which is this matrix. Now this matrix has determinant what? As equal to 1, and you can write 1 as 2 raised to power 0, where what is 0? 0 is an integer. Therefore, it follows the conditions of this subset. Therefore, it is also a member of the subset H. Hence, we say identity is present in H. So, this satisfies our first condition over here. For the second condition, we have to test, we have to check this test, subgroup test. So for that, we need to consider two matrices A and B. Now we are taking the matrices to be non-singular. Why? Because we wanted the inverse of matrices, and the inverse exists only when the matrices are non-singular in nature, such that A and B are present in H, correct? So therefore, when we consider A and B as members of H, so that means the determinant of A would also be some power of 2. And the determinant of B would also be some power of 2. Let's call the powers to be n and m, correct? So let's call the determinant of A to be equal to 2 raised to power n and the determinant of B as 2 raised to power m, where both n and m, they are integers. Correct? Now we have to check what is the determinant of AB inverse. Why? Because for two matrices A and B, if they belongs to H, if AB inverse also belongs to H, then we'll be saying that by one step subgroup test, we have H as a subgroup. Correct? So we are checking this condition onto AB inverse. So that means we are checking it onto the determinant of AB inverse. So you know determinant A into determinant B could be written as determinant A into determinant B. So we have expanded this expression, determinant A into determinant B inverse. Now the determinant B inverse could also be further written as 1 divided by the determinant of B. Now we have substituted the values of determinant A and determinant B over here, right? By the laws of exponent, you can write it like this, 2 raised to power n minus m, where what is n minus m? That is also an integer. Why? Because the set of integers that is closed under the operation of addition as well as subtraction. So now we obtain for two matrices A and B from H, we now obtain AB inverse present in GL2 comma R such that the determinant could be written as the power of 2. So that means this follows all the conditions of H. So that means this AB inverse is present in H. If AB inverse is present in H, so by the first one step subgroup test, we can conclude that this H is a subgroup of GL2 comma R, and this is what we wanted to prove here. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.